Hi guys, hope you guys are all well, and I'm going to start my next video in the series, which is to build the snake game. I didn't realize how long the previous video took. I just recorded it and then just uploaded it directly, but it was close to like 25 minutes, and hopefully this video will be slightly shorter, and I'll try to go a bit faster as well. I realized I was explaining like every single small detail, but yeah, maybe I'll try to do a shorter video that could just give a more bite-sized version of how to do this, how to build a game. So yeah, Snake Game is a very popular game. We have had the Nokia version of things, and we had the smartphone version of things. Then we had the multiplayer version of things. And yeah, these are some components of the snake game, which is snake head, snake body, the wall. Like if you touch the wall, you die. If you touch the foot, you grow, etc. So far we have built we have started, we have gotten the screen to load up, and we have also built the snake head, which reacts to our arrow key commands. And today we will work on snake foot and snake body, and hopefully I can finish the video within 10 minutes, hopefully, but more likely I'm going to overshoot the 10-minute limit that I set for myself. Okay. So yeah, I found a foot picture. Yep. So let's get straight to the coding. This is the code that we have from the previous video. So what I'm going to do is I'm just going to continue from here. We built the screen, we built the snake head, and then we built the listening to the arrow and the keyboard commands. And we also have some small little functions here to help us move. And we also have an infinite loop at the bottom, which will update the window as things change. And we also have a move button to ensure that this head moves in the direction that we want it to. And this part where we say time.sleep delay is up over here at the top. Maybe I should, yeah. At line 4, this sets the speed of the game. So if I want the game to be super fast, I can reduce the delay to like maybe 0.05 and things will get really crazy. Like things will move really fast. That can be like a way to set the difficulty level for yourself. Anyways, let's get straight to coding now. So as mentioned, we are going to start with the snake foot. So as with any, okay, wait, let me just try to run the code first so that you know that I'm not bluffing. So save it, run it. Why is it not running? Yep. So this is the snake game. So far we are the head that moves around and it's able to go through the walls. It doesn't have a limit for itself. So yeah, all these things we'll build as we go along. Right now, I'm going to close this and I'm just going to put this at the side. Do I need this? Yeah, I'll just keep it at the side. It's fine. It doesn't really bother me that much. Okay. Now, let's go up over here. And right below snake head, I'm going to create something called snake foot. So snake foot is the food that the snake will eat. And then if it eats the food, it has to grow bigger. So yeah, hopefully I can get to, did I say I'm going to finish the body today? Okay, that's going to be quite tough, I think. Okay, anyways, let's continue coding. The snake foot is like any other graphical package. You have to initiate it first. tx.turtle and foot.speed 0 and foot.shape. I'm going to call this shape circle, and I'm going to, you know what, foot.color, the American spelling color. I'm going to call it red. I'm going to have a red circle that would be foot.pen up so that I don't leave a tracer when I move the foot around. And foot.go to 0 and 100. So by the Cartesian plane, which is the XY axis, Y axis, and X axis. This thing is going to be really, really important. So coming in the for this video. In fact, the whole series about snake game development, the Cartesian plate XY axis is very important. So what I'm doing is I'm basically creating the foot object at 0 x and x axis and 100 y axis, which would be somewhere around here. Our whole length of the x and y axis is 300, 300, 300, 300, which is why we have this thing over here, 600, origin being at the center. Okay, hope that clears things. So next up, now that we have the food item created, what we need to do is we need the food item to move around if we hit it. So to do this, it's quite simple. We first need to check if we hit the food. Like our head object must hit the foot object. So to do so, we are going to use quite a simple method, which is to just check if the coordinates are in proximity with each other. So we can find the head's x-axis, y-axis. We can also find the foot's x-axis, y-axis. We just compare and see if they are near each other. Okay, I promised I'll explain less things in the benefit of time. Head dot distance. Oops. So in total package, we have this benefit of using this tool called distance, which helps us compare how far away items are with each other from each other. In this case, head to foot, the distance, if it is lesser than 20, I'm going to count it as collided with the foot. So foot collision. If it has collided with the foot, I'm going to move the foot. So to move foot, I'm going to use the random package, which we have not imported yet, but don't worry, I'm going to get to it shortly. Okay, the random package, essentially what it does is I'm giving it a range, -280 to 280. So within this range, it's going to choose a random value, and that'll be my x-axis. Likewise, for my y-axis, I'm going to copy this. Oops. And this will be the position of my new foot object. Okay, so let's see. Am I missing something? Yep, random. So random is a package that we have not imported yet. So we need to import the random package. I'm going to import random. And that's it. So random package is a package created by mathematicians to help us with the randomization of the process, which is what makes the game fun as well, because it's slightly unpredictable. Like where will the foot go next? So all I'm going to do is I'm going to say foot. You go to this new position, which is X and Y, which is just a random coordinate that we have created earlier. And with that, we are done. So let's save this and run it now. Now, every time I touch the foot, it's going to disappear and move to another place. All it's doing actually is it's just going to another place, but it's so fast that you can't really see that it's going to another place. So it gives the illusion of it disappearing from its existing spot and reappearing in another spot. So yeah, I will close the program. With that, we have finished the first part, which is snake foot. The next part is a slightly harder challenge, which is once you eat the food, two things must happen. One is the snake must grow a bit longer, and the next thing is the tail of the snake, that means whatever is connected to the head, must follow in the head's path. That means, if okay, let me just draw out a simple example. If this is the head, and okay, I'm gonna choose a different color, and this is the tail. If the head moves over here, the tail must follow it like this. If the head moves like this, the tail must also move like this. It cannot be like find a shortcut to get here. So to do this, what I'm going to effectively do is I will have an array of items and I'll store the position of this. I'll store the position of this somewhere. I'll store the position of this somewhere. And I'm basically, as I'm moving to the next item, this item's position goes to this one. And this item's position will go to this one. And this has to be a constant loop such that it will just keep doing this consecutively in the infinite loop that we already have. So yeah, that is the idea behind it. But for some people who would rather see it as a code, I'll just code it out now. Okay. So first step is we need to create a new food item. I mean, the new body. So I'm going to create a new body. So once I hit the food, once the head hits the food, I'm going to create a new segment, and the new segment will be a tx.turtle, which is as usual, like any graphical package that we are loading using the turtle package, we have to instantiate it like this. So new seg dot speed 0, new seg. I think I'm getting a bit tired of all this typing. Dot shape is square. New seg dot color is green, and new seg dot pen up. And lastly, what I need to do is I need to create outside the while loop. I'm basically keeping track of all the segments. Like we cannot have a segment that keeps getting created inside the while loop. So I'm going to create a segment array outside the while loop, and I'm going to add the new segment to my my segments array. So segment dot append new seg. And with that, we have we won't be able to see, nothing would actually get graphically presented now. Like if I eat this, it'll just create a new item like that. And if I eat more things, it's just creating more and more body. Whoops. It's just creating more body graphical images at the origin 0, 0 in axis. What we needed to do is we need that body to attach itself to the head's position and keep following the head wherever the head goes. So to do this, we are going to make use of the while loop and the infinite while loop that we have over here and move the body accordingly. So to do this, we have done when we eat something, we are going to create a new body. All we need to do now is make sure that all the bodies that are in the segment follow the head. So to do this, what I'm going to do is I'm going to do something like, I'm going to create a for loop to move the body. For I in range len segment x is equal to segment I minus 1 dot x core y is equal to segment I minus 1 dot y core. Oops, my bad. Sorry. We're basically finding we're getting for I in range, whatever length the segment is, and we are going from reverse now. So we are going from the back to the front. So to get in the reverse order, we need to do something like this. From the maximum length to the 0th index, and we go in the order of decreasing order, which is -1. And that's how we get this. Why we are doing this is because we need a way to, like, let's say we have a array of new segments and we have a head. when we append something to a snake, it'll always get appended to the end of the thing. We'll always append to the last part. It's always in this direction. Hence, when we eat something and we add a new item to the end, we just rather have the last part follow the snake head. So this will follow this, this will follow this, this will follow this, and this will follow this. So that's the easier way for us to handle this. So we will be doing that. Segment I dot go to X, Y. And this is just another part of things. If the segment is greater than 0, if the length of the segment is greater than 0, we are going to have head dot x call, y is equal to head dot y call, and segment zero, that means the first item is going to go to xy dot go to xy. Segment 0 go to xy. And yep, I think looks okay. I'm just going to put the move item at the bottom. I'm going to actually put both of these, the time.sleep at the bottom as well, so it's easier for you to visualize. Like the idea is we do all the calculation, all the fancy things at the top, and in the end of the day, we just let them move in the direction that we want it to go. And then we also delay the infinity loop at this point. Okay, so far we have done quite a bit of things. We have created, let's just run this now, see if it works. Okay, it stops. For I in range lens segment, seems that I made a mistake. Line 85. Okay. When I say lens segment, a length of a segment in this case would be 5, 0, 1, 2, 3, 4, 5. But if I were to start from 5, it would be index 5. It'll be 0, 1, 2, 3, 4. Index 5 doesn't exist, and hence I have an error. So it should be 1 before that. So this is the answer. So let's run this now. Hopefully this works. And yep. As you can see, my tail follows the head as intended, and I'm growing at a pretty good pace. Right now, I'm not dying if I touch the walls. I can just come back as I like, which was actually one of the modes that was present like in one of the early Nokia games. Like you could go through the walls. Another technique that they had was you could go to this side of the wall and come out from the other side of the wall. Okay, wait, I need to reverse. Because we haven't created the wall collision mechanics for the game. And actually, I think we have managed to finish our objectives for today's video, which is create the food item and create the create the body to follow the head, which is, in my opinion, the hardest part to understand about the game development mechanics. All it's doing is it's just following its predecessor's position, and that's how we get the get the snake to run in a normal fashion. A way to make it a bit more interesting would be to check for body collision, which would be one of the next few videos content, border collision and body collision, which you can look forward to in the next video. And with that, I will conclude this video. I think it has gone quite long already. I've lost track of time, and hope you guys enjoyed it. Feel free to put the video at times 1.5 speed or something if I'm speaking too slowly. And do leave a like, share, and comment it if you found it to be useful. And I'll see you guys in the next video. Thank you.